Hello.
Yeah.
Okay. So today we, yeah, I can see you the images diagram.
And so today we wanted to discuss the difference between the OLTP and Olap.
Yes.
Yeah, so yesterday we had some discussion in the towards the end point of the course or end
Mm-hmm.
point of the class. So we happened to discuss few of the things like the transaction database and the warehouse database.
Mm-hmm.
So ETL is the process which is widely used in this environment, like to populate the data into warehouse. And
Akul, a
we have
little, your volume is little, little low. Can you little bit of increase something?
okay, just
Yeah, also your voice, I think yes, your voice is still improving. It's okay.
yes.
Okay, okay. No, you're okay today, or you're sick, kind of, you're fine.
Still, it's not fully recovered actually.
Yeah, I know. That's it. Is it okay for you? Because if you uncomfortable, I can go with you. Always, I want to give you cooperation, whatever the way.
Yeah, no problem.
Mm.
Yeah, okay, I will take the mic near
Yeah, okay. No problem.
the.
If you be comfortable, okay, so we will go according to your comfortability.
Yeah, sure. Thank you.
No problem. Hmm.
Okay, so this is what like yesterday towards the end of the class,
Yes.
we started this discussion:
Hmm.
the transaction database versus the warehouse database.
Yes.
So normally in transaction database, we find detailed data regarding day-to-day business events or transactions.
Hmm.
And here it is said to be like you'll have like current data, not history.
Right.
Warehouse is meant for history, and the data of this database is mainly manipulation oriented. That means this database is mainly uh, like optimized for data manipulations.
Hmm.
It is consistent for data manipulations.
Right.
It can handle well data manipulations. Like often it's a volatile database, we say.
Right.
Often new data comes in, existing data might be modified. And when you talk about the usage, so many people work around here. High concurrency you find, like concurrent users are nothing but like simultaneously working with the database.
Okay. Okay. Hmm.
So many people can work around, and with this database I always expect faster response, like
Hmm.
performance. It is very important because this database is supporting my business operations.
Hmm.
It is the backend for my business applications.
Hmm.
Okay, so obviously I require a faster response.
Okay.
I expect it should be optimized for faster response.
Hmm.
Mm. Performance is the main criteria here. If the database delays the response, the business event or the business process also will be delayed because of it.
Okay.
Okay. And normally the size of this database, if you see, it will be small to medium, like it won't normally go into large size or very large, because we try to maintain limited data over here, limited number of transactions. Like transactions occur a lot many in organization, thousands or maybe millions.
Hmm.
So every day thousands of transactions occur in organization, like in a business, and every transaction I'm keeping a track into the database. Okay. So like that, if I accumulate the data, it will become like millions of transactions. in few days. Like this, if I try to maintain data for a very long period, hours, like very long time durations, periods actually, like months or maybe years kind of stuff. So my database size will grow very large. Okay. When the data size grows very large, obviously I have the issues of not only the maintenance of the data or managing of the data, but mainly the issues will be with performance. Okay. So having a storage capacity is not a problem nowadays. Storage is very cheaper nowadays. But the like consideration of performance is also important. That's why people had a practice of not having uh, history like lifelong storage here. So they try to keep only some limited number of transactions here which are required to run the show. Like it can be, that is decided by the nature of the business or the requirement or the strategy practice. So it can be only few weeks of data I may keep here, few weeks of transactions, or maybe few months or few quarters or few years. But it is not lifelong. It depends upon the like nature of the business. For example, if you take like for example, you take some example like Indian Railways, let us take. Indian Railways, they have a database, na, obviously.
Yeah.
They keep a track of each and every transaction. So every booking is a transaction here.
Yeah.
Every day millions of bookings will be done okay, across the country. So all these transactions, if I try to hold in my database, for lifelong it is very difficult. It is not possible. No? So how long I should keep my transactions in my transactional database? Operational for operational purpose. How many days? How can I define the life of the data or transactions in transactional database? What do you think? How many days they can keep railways?
I have no idea how the database, how big or how much they can keep it.
No, normally if you have a transaction stored in database, what can be the life of it? Like how long I require it there in operational system?
Maybe a year, 1 year transactions can be year to year. They might move it to our.
Yeah, in many systems maybe they go for year to year. Okay, but in railways actually once the journey is done, okay, do I require the information in transactional system? Operational system may not be.
May not be, yeah.
Okay. So that means I can plan a journey few months ahead. Okay. So hardly I can handle or keep the transaction in the database for few months, maybe 2-3 months.
Okay.
After that, 2-3 months old information where the journeys are done,
Okay.
I can move to a backup or I can plan some archiving. Okay. I need not to keep in the transactional system because it will impact even the performance of it. Okay, so I can have a practice like this. It can vary. The life of a transaction, it can vary from practice to practice, business to business. Okay, nature to nature, like that. So that's why it can be few weeks or few months or few years.
Okay.
But you'll never find lifelong data here.
Okay.
Okay.
Yeah.
So that's why we have a plan separately for historical storage, a warehouse or a data mart. So, and the scope of the data of transactional system is it's a single organization scope. What do you mean by single organization scope?
Only concerned about the particular business or transactions.
Yeah. Whatever data you have here is only concerning about that particular business here. And this database availability I can plan 24/7. These databases can be highly available, or they can be online. Okay. So I can go for round the clock business. So when you compare this with warehouse, okay, so warehouse normally is planned for historical storage of data, and data is summarized here. Like actually, in transactional system, the information is kept is detail. At what level the details are kept actually? Details of each and every transaction. At every single transaction level, you have the information.
Yeah.
Details of every single transaction you have there. But here, the same information we can never get here. Like we don't keep the same details here. At the same detail level, we don't keep the information in warehouse. So then, so at what level you keep? What level you keep? So why you don't keep the same level of details in warehouse?
For the decision making, we don't need that details. Only the summarized details for enough for the management level, right?
Yeah.
Okay.
So at a required level, data should be summarized.
Okay. Okay.
They don't require the same details, obviously.
Right.
That's why you say it is summary data you have here, and it is historical data.
Data.
And once you store the data here, so we store it for the purpose of queries, business queries. So the database is query oriented.
Okay.
Okay. So it should be optimized for queries. That is the reason. Transactional databases are to be optimized for manipulation. This is to be optimized for mainly queries, because we don't manipulate the data.
Okay.
And the concurrency of users, if you compare, comparatively, it will be low. Okay, low concurrent when you compare with transactional database.
Yeah. Yeah.
Because few users will be using.
Only management level. Some.
Only management level. Yes. Yeah. And this faster response can be optional. Okay. And obviously the size of the database is very large. And how can you say the scope of the data is multi-organization scope?
Multi-organization means if the organization is in a different locations or different different part of country, then all together they will bring it together and they will analyze that kind. Or
yeah, in that manner, like the scope of the database will be multi-organization.
Right.
And the
Multi-organization
availability.
means under the same business, right? The same management.
Yeah, under the same management, exactly.
Okay.
Yeah. And the availability of the database can be on demand.
On demand.
It need not be available 24/7.
Whenever they need it, they will pull it.
Yes.
Okay.
So because these people, they never spend like 24/7
Yeah, exactly.
time on this. So whenever they require, I can make it available on their demand.
Right.
So based on the like warehouse database data, you go for Olap process, and that gives the knowledge to the end user. Okay.
Yeah, I got it.
These reports can be presented to the end user, decision makers.
Yeah.
Like this. So this is what we were discussing. Yesterday we have gone through the definition of the warehouse. No?
Yeah.
So this is the definition given by INMOM.
Yeah.
Subject-oriented non-volatile time variant. Integrated database to keep historical data along with current data in summarized form for the purpose of analysis to support decision making or future planning.
Right.
And actually there are main features of warehouse which you can always compare with the transactional system. Okay. So already few of the things we have already gone through. Okay. So there are main 16 points, okay, which you can just discuss how it is different in Oltp. So when you discuss about the purpose of the warehouse database, The purpose of the warehouse database is analysis.
Yeah.
Analysis information to
Mm-hmm.
get the patterns and trends of the business. What is the purpose of transactional database?
It's analysis. No, transactional database. Okay, that is to run the business.
Yeah, that is to run the business.
Mm.
The users in who uses the warehouse data is mainly
Management
managerial
users.
people, management.
Decision.
But there, if it is transactional database, who will be the user?
Yeah, even the customers also can be a users, right?
Yeah,
Or they,
mainly employees are the users,
uh-huh,
employees of the organization,
uh-huh.
and sometimes even customers can be.
Can be. They update data. They register or kind of credit card transactions. They update like purchase, online purchase, etc.
Yeah, even yeah, customers also can do that now. The
Mm-hmm.
systems are allowing customer interaction.
Okay.
So users of transactional system can be employees as well as customers.
Customers.
Okay, concurrency we know this is low here and in transactional database it will be high.
Exactly. Uh-huh.
What about session duration?
Session duration. Can you please explain to me about the session duration? Akul?
In a transactional system,
Uh-huh.
session duration is nothing but the time of connectivity to the database. How
Oh,
long would you connect?
or the
Like when you
traffic.
do the transactions,
Uh-huh. Uh-huh.
transaction should consume very less number of, like very less amount of time.
I see.
Within short span, it should finish its work and it should cut the, it should complete its work. Yeah?
Exactly. Yes.
If you are trying to plan a transaction,
Uh-huh.
to complete the transaction, you need database connectivity, interaction of the database.
Uh-huh.
Okay, you need a session.
Right.
So when you start a session with the database to complete the transaction, how
Uh-huh.
long it should span? It should
Okay.
be very short
Okay.
because it should always have the performance. No? The transaction should be always done very quick.
Quick. Yeah.
It should always have performance. So we see that durations are very short, the
Mm.
interactions.
Okay.
But here, when business users are using,
Mm-hmm.
so obviously the query runs can be very long
Oh.
or the interaction with the database can be very long. So
Okay.
that's the durations, obviously it will be longer
Mm-hmm.
when you compare with the transactional system.
Okay. So that means that transaction takes place hours together or days together to run a query.
Like transaction, okay, cannot take like days or weeks, but a decision making will take actually.
Oh, okay.
Okay. But actually, but that long they cannot be connected to the database. But if they start a task,
Mm-hmm.
finish it, they'll take a lot of time. Okay,
Okay.
they might sit in different intervals in different days,
Mm-hmm.
and they get it finished, but it will take a lot of time for them. But if you uh, compare the database interaction, it will be longer than transactional system.
Yeah.
It might be minutes and hours,
Right.
but it cannot be days and weeks, obviously.
Okay. Okay.
Database interaction cannot be days and weeks.
Mm-hmm.
So we know the size of the database, it will be very large here, but the transactional database can be small to medium. And the life of the data we know, here it depends upon your strategy and plan. It can be for years you can keep, it can be lifelong or it can be up to certain years, no, minimum. So
Oh,
to have good analysis, at least if I have to say at least 5 years of data, you can go for some good analysis.
all right.
5 to 10 years of data.
Okay.
It can be more than that.
Uh-huh.
Scope of the database, multi-org,
Some,
this we have seen.
yeah.
Response time,
Uh-huh.
response time, if you see transactional databases response time, we expect to be very fast, but this can be moderate.
Mm-hmm.
If it is fast, that is, but It is not a compulsion.
Yeah. Okay.
So these are the first 8 comparisons. The next 8 comparisons are like this.
Mm-hmm.
The next 8 comparisons are obviously definitely important also. The
Mm-hmm.
first one is more important, like data model. What do you mean by data model?
So dimensional. No, where in transactional?
Yeah, here it is dimensional there.
It's a relational, mm,
In transactional database, okay, model will be relational model.
yeah, entity relational model. Okay. Uh-huh.
So what makes the difference actually?
So they have means there it would be normalized and all the tables will be separated and they given a relationship between the tables
Yeah.
and data normalized data will be there.
Yeah.
Mm-hmm.
Normally ER model is preferred for the databases where DMLs are highly possible. Okay.
Okay. Uh-huh.
So this model is morely like it is more consistent with these kind of environment, transaction processing environments.
Okay.
That's why normally the databases we come across in operational systems, we find it modeled in relational model or ER model.
Mm-hmm.
So what this model talks about is data storage is done in terms of like in tabular formats, no?
A table form. Yeah.
So table is having a structure which is a two-dimensional structure. Okay, and these tables will have relationships.
Right.
So obviously this talks about collection of tables with relations, obviously.
Mm-hmm. Okay.
But the structures are two-dimensional structures. Okay, table it's a storage structure. No? The
Mm-hmm.
table will have a structure of storage that is a two-dimensional structure like rows and columns.
Okay.
Okay, so whereas warehouse model is a dimensional model.
Okay.
That is, this model talks about dimensionality, like multi-dimensional storage
Uh-huh.
structures,
Okay.
not two-dimensional. Okay,
Okay.
so in warehouse we talk about data storage done in terms of cubes.
Oh, cubes. Okay.
Yeah, so cube is a multi-dimensional storage structure for data. Okay, so why you prefer that structure is that structure is good for query handling.
Okay.
Okay,
Mm.
so relational structure is good for manipulations mainly. It is
Okay.
consistent with data manipulation.
Uh-huh.
Okay, because so like relational model is in practice from 70s. Okay, before 70s people were using many other models like some other models, old models.
Mm.
People used to have data storage in flat files also, and they used to have models for storage like hierarchical model, network model like that. Some
Mm.
older models were there
Mm.
which have a lot of problems.
Mm.
One of the problem was data redundancy
Mm.
and inconsistency, complexity, okay, security,
Mm.
okay. These all were the problems earlier.
Mm.
People used to face when they go for data storage.
Mm-hmm.
Okay. So many people spent a lot of time in researching to solve this. Okay. And finally, they have come up with a relational model
Mm.
which minimizes all of it,
Okay.
which is a great solution over time, okay, in history for data storage, database solution. So it eliminated like redundancy problem, like it minimized the redundancy of the data in database. We know through normalization we do, okay,
Okay.
and it is consistent and it is flexible for data storage and manipulations. So it got to be a proven model now. But it is being widely used
Okay.
for data storage. Actually, as time evolved, like people found the necessity of having another kind of database is for historical storage. Okay, earlier people never practiced storing history, because storage capacities were very costly earlier, no?
Yeah,
In
yeah.
the older days.
Mm-hmm.
So later they realized when the a need evolved, a need of having decision making, planning and analysis of data,
Mm.
they have found the importance of history. So then they have like people, definitely many people involved. Like there are two main people who
Mm-hmm.
were under who were behind the theories of the warehouse.
Yes.
Okay. So they have evolved with a model here, dimensional model. So where data storage is facilitated in a multidimensional method,
Mm-hmm.
where queries become flexible. Queries are optimized.
Okay.
Business queries. Okay. That's why the model difference we have. So we'll discuss more regarding this model anyhow.
Okay.
Okay, this is one major main difference that we need to understand. The other difference is obviously normalization.
Okay.
Okay, warehouse database is highly denormalized,
Okay.
whereas transactional database data is highly normalized.
Mm-hmm.
We know this.
Okay.
Later we can even get into like how exactly it is denormalized or how exactly find redundancy in warehouse and all. We can
Okay.
see.
Okay.
And the security level for transaction database, what kind of a security required?
It's high level.
Yeah. For this,
It's normal level is enough, right?
okay. What about reliability of data?
In transactional, we need high level too.
Yeah, there also, because
Yeah.
if it is not reliable, there
Exactly.
is no need of database itself.
Yeah. Exactly. Yeah.
The purpose of database itself is
Yeah.
believing the information whatever it gives.
Yeah.
When I cannot rely on it, it is meaningless. So reliability is always expected in any kind of a database.
Mm-hmm.
Okay. So to keep up the reliability, so how you take care in transactional databases?
It must be highly secured and must be faster database.
So in transactional databases,
Uh-huh.
this part is implemented.
Uh-huh.
Okay, like maintaining the integrity of the database.
Mm.
Okay, that is implemented using constraints, integrity constraints in the database.
Okay.
That means before
Primary.
data comes to the database itself,
Uh-huh.
like at the time of data entry or modification itself,
Uh-huh.
I go for checks, integrity checks.
Okay.
I take only that data which is valid according to my need.
Okay.
I
Mm-hmm.
don't entertain invalid data.
Okay.
Obviously, when you load the data to the warehouse also, you can always take care.
Mm.
Right data goes in. Once the data goes in, so whatever you retrieve, it is always valid,
Mm-hmm.
because you are taking care that what goes in is always valid.
Right.
Okay, that is the right way of implementing. Okay. So reliability is always required for any kind of a database.
Mm.
To blindly believe the information given by database.
Mm.
Okay. And the availability we know on demand here, and that is online. The high availability is required for transactional database.
Mm-hmm.
And event type, it is data query event which occurs often,
Mm.
and their manipulation of occurs often.
Yeah. Yeah.
And the level of summary, summary data we find here,
Mm-hmm.
and detailed data we find there,
Yeah.
and application type.
Yeah.
Here we use analytical applications. There we use transactional
Application.
applications
Okay.
like this. These are the main points to be compared to have an basic understanding. OLTP versus OLP.
Okay. Yeah, it's very clear.
So we know what is a warehouse now.
Yes.
So always we hear about, apart from warehouse, we always hear about data mart also.
Mm-hmm.
So what is a data mart?
Uh,
Warehouse we know.
Yeah,
If
what
it's in base,
I read something. It says a subset of data available from the data warehouse. Subset of data
yes,
warehouse.
yeah, you can, in
Uh,
a way, you can define data mart to be subset of a warehouse.
yeah. Okay.
You can say that.
Mm-hmm.
Other terms, some people say data mart is like a warehouse.
Okay.
Okay, data mart is like a data warehouse. They say, or some people say data mart is a warehouse.
Okay.
Data mart is a data warehouse. They say.
Mm-hmm.
Okay, so all these statements can be proved true. Okay, to have a simple understanding of it. So data mart is nothing but it's like a small warehouse. You can
Okay.
say
Mm-hmm.
data mart is a warehouse, but it can be like a small
Small.
warehouse. You can say.
Mm-hmm.
To get an exact definition, here you have data mart is a warehouse for specific domain or set of very closely related domains. That means what is the purpose of a warehouse like in an organization?
To take a decision making or
To
analysis.
support, yeah, to support the decision making process of organization. Okay.
Mm-hmm.
I need a solution for decision making support of an organization. So as a part of solution, I'm planning a warehouse. If I need support for the decision making process of the total organization,
Mm-hmm.
obviously I consider to have total organization data in my warehouse. No?
Yeah. Yeah.
But if you are planning a specific solution, not for the total company,
Mm-hmm.
if the solution is planned for a particular corner of your business or a
Okay.
particular domain or a particular like branch or particular department like that.
Mm-hmm.
Okay. So then I plan a warehouse specific to that area. No?
Okay. Yeah.
So that small warehouse becomes a mart. Like that, I may have multiple marts in my business.
Okay.
So all these marts can make up my enterprise warehouse.
Mm-hmm.
No?
Mm-hmm.
So then it becomes subset of my actual warehouse.
Okay. Okay.
So that is why people say data mart is subset of warehouse.
Okay.
Okay. If I plan warehouse small for every corner of my business, for every area of my business, like every domain or every department like that,
Mm-hmm.
all together makes up my total warehouse data. No?
Yeah. Yeah.
That can be consolidated to be my total enterprise warehouse.
Okay.
They become subset of my warehouse.
Yeah. Yeah.
So, so when you talk about data marts, there are two types of data marts: independent and dependent.
Mm-hmm.
Okay. So there are always two types of approaches.
Mm-hmm.
Like accordingly, like this is not elaborated, but accordingly, like we have two series of warehouses now from two fathers. Warehouse is said to be two fathers, having two fathers,
Yeah.
Inman and Kimball. Okay.
Okay. Okay.
According to both of them, there are two theories. Okay.
Mm-hmm.
So two approaches to set up a warehouse. Okay. One is bottom-up approach,
Mm-hmm.
and another is top-down approach.
Mm-hmm.
If you talk about bottom-up approach, how I plan my actual warehouses, I plan marts, okay, for different areas of my business, like different domains or the different departments. I consolidate that for the actual warehouse later.
Mm-hmm.
My implementation, how I start is, I start mart-wise.
Mm-hmm.
One area I take and I implement marts in all those areas. So each mart can support decision making at that level,
Okay.
no, at that domain level, at that department level.
Mm-hmm.
But to have a total solution for organization, I need to consolidate all and I should get a enterprise warehouse. Okay. So then here, this mart is called to be independent data mart. That means the mart never depends upon warehouse for data. Warehouse depends upon the mart for data.
Oh.
It is called as independent data mart in
Okay.
this kind of approach.
Okay. Mm-hmm.
Obviously, the other approach is
Yeah, all right.
first you plan the total warehouse, actual warehouse, enterprise warehouse,
Mm.
and that can support the enterprise level decision making. But to have decision making ability at particular area of the business, at like domain level or at department level, you can like extract so that particular information to a map, and you can plan decision making at that level.
Okay.
If you are planning this kind of an approach, like from total warehouse, if you are trying to have like marts for that level decision making support, it becomes top down approach, and here the data marts depend upon the warehouse for data.
Okay.
They become dependent data marts.
Mhm.
So two kind of approaches normally used.
Okay, I have one question. You now, you said a dependent, independent, right? So, okay, dependent, yeah, independent is coming directly from the transactional source to the
Okay.
data mart. There it we do all the ETL process, and finally summarized data will be stored in the particular subject in every data mart.
Okay.
Okay. After that, when it goes to the data warehouse, only the copy of the set goes to the data warehouse, or again one more ETL process summarizing or some process takes place between data mart and the data warehouse.
Yeah, here it can be again extract and load, but I may not require transformations then. No?
Just one set
I
of
need to
copy will
just
go there.
yeah, yes, copy will go there.
Only one set
I
of
need to
copy.
just yeah, I can consolidate all this. That becomes my warehouse.
Or it's just kind of consolidation together, putting together all the extracted data goes to the data
Yeah,
warehouse.
yeah. The best solution can be instead of again copying the data, na,
Uh-huh.
if I can consolidate, it can make up my warehouse actually.
Okay, what is the purpose? Again, we need to put it in the data warehouse. So anyway, it is all separated for each.
No, yeah. Like for example, when you work at a particular mart level,
Uh-huh.
you can have decision making only at that particular area,
Yeah,
at
okay.
that level.
Uh-huh.
You can never go for total enterprise level decision.
Okay.
For that, I need to have all the parts of my business together. No? So I need consolidation of all these together.
So if you want a together decision, suppose if we want to all together,
Overall,
overall,
yeah,
yeah.
enterprise level.
Okay.
For enterprise level decision making, I need information from every corner of my business.
Okay. Uh-huh. Yes, yes.
So obviously, I need to have all this on hand.
Okay. And also one more question. So even data marts also the data will be denormalized.
Yeah, data mart also will have the same features of a warehouse. Like here also data organization will be subject oriented.
Mm-hmm.
Okay, integrated, non-volatile, all these things, same features.
Same
Only
logic,
thing is its scope is different.
different.
The
Okay.
size is different. That's it. All the other characteristics are same as warehouse.
Okay. Okay. That means even other way also only copy of the set we will just bifurcate like from data warehouse to data mart. Even if you want to subsection means if you want to move section by section, that means just a copy one set of datas will go to data marts, right? Am I correct?
Yeah,
Okay.
yeah, yeah.
Okay. Okay then. Okay. I understood. Okay.
Okay. There is another term like staging database. What is staging database?
Uh-huh.
In ETL process, often people use staging. Like in between source and target, okay, if you are handling the data, storing the data, that becomes staging area. The storage becomes staging database. Means from source we are extracting the data.
Mm-hmm.
In a stage you are not transforming and dumping to the target. Okay. But you are handling the data in middle location.
Mm-hmm.
Okay. So that becomes a staging.
That means between source and
Yeah.
target, always it goes to the staging, and then process takes place in the staging level.
Yeah, yeah. Let me explain.
Okay.
See, I have a source.
Mm-hmm.
from which I should extract the data and transform and load it to the target.
Okay.
So the data, whatever I extract, I do all the transformations and then load to the target. Okay.
Mm-hmm.
So whenever I'm doing some ETL process, okay, for data extraction, I'll be engaging the source all the time.
Yeah.
All the time, whenever I'm running ETL, the source is engaged. No?
Mm-hmm. Mm-hmm.
The source is busy.
Busy.
But one thing we need to realize that this source is even busy with operations. No?
Oh yeah, yeah. That is always 24/7. It's keep running
Yeah.
towards the. Okay.
So I should think of it that is the load on this source. Okay.
Oh.
So that is why one way what people do is to minimize the load on the source, they plan staging. Okay. What they do is they go for staging and they extract the data and simply load to the staging database.
Oh.
That means whenever the source is free
Okay.
in non-peak hours,
Mm-hmm.
I can take care of extracting the data, whatever is required for ETL from the source, and I can load it to the staging. And now staging database is 24/7 available for ETL.
ETL. Yeah.
Okay. So I need not to disturb the source for ETL now. Okay.
Mm-hmm.
So from here I can plan ETL.
Okay.
Okay. So this concept is called as, like, here we have two concepts. One is source independent extract.
Oh.
And so, okay, sorry. Yeah. Sorry, source dependent extract it is. To extract the data, yeah, to extract the data from source, we depend upon the source and we extract to get it loaded to the staging. Okay.
Uh-huh.
From staging, it becomes source independent loading.
Oh. Okay.
So to load the data to the warehouse, I don't require source because I have everything in staging.
Right.
I engage staging, not the source. So staging is like very useful, like it is practiced in like all environments actually.
So that means so in the stage, all the data of a source will be set of copy just coming just like that.
Yeah, just what they do is just as it is they dump here without any transmission,
Okay.
and then from there they can engage it for ETL.
So that means we call also ETL also, right? If it is source and staging also we call as a ETL process.
Yeah, ETL, but T won't be there. Like there won't be transformations maybe.
Oh. Only
Just you
extraction and
extract
loading.
and as it is load.
Oh, okay.
Extract and as it is load.
Right. The transformation level takes place between staging and target. Right. Okay.
Yeah.
Okay. Okay. Very clear.
So stage also like we come across, okay, in these environments. And there is another word you come across, ODS, operational data storage,
Okay.
or operational data source. Yeah, ODS.
Both are two different, right? Operational data source and operational data storage is totally different or same?
Yeah, some people call it like that. Okay. Operational data store or operational data source.
Both are same, the wordings?
Actually, this is to be called as store only because it is a storage area. Okay. Operational data store, you should call it actually.
Okay. So sometimes transactional database is also called as a operational data source.
Yeah, that changes the meaning. No? We
Yeah.
cannot call this as
Yeah, okay.
operational data source. We cannot call it as a source.
Okay. Okay. Mhm.
But this database might become a source for warehouse.
Okay.
Okay.
Mhm.
But how exactly we understand ODS?
Uh-huh.
This is actually planned for integration purpose. Okay.
Mm.
This database is planned for integration purpose. Like this is not planned for warehouse purpose. It is planned for integration purpose.
Right.
That means I have different branches. Okay. all these branches are in different locations and the data is in different platforms.
Mm-hmm.
I'm just planning a single point of access. I'm not planning a decision-making solution, but I'm just having a plan of having single point of access. Then what I can do is I can plan an ODS.
Okay.
So for the purpose of integration, I keep all my different uh, department data, different platform data, or different form data in one location, one for the purpose of integration I can do. So any information I require, I have a single point of access. But
Okay.
this solution may not plan for decision making.
Mm-hmm.
Okay. So it can happen in intra-banking transactions or B2B transactions. That means, for example, if you take bank, see, for example, when you try to take a loan from a bank, what do? They put a lot of questions. No?
Yeah, yeah.
One of the important questions they put, did you take any loan from any other bank?
Yes, yeah.
Okay. What do you say? Yes or no? But they won't simply believe us. No?
Yeah, they will run the credit history.
Yeah. So earlier, older days, they used to send a request to other bank to verify whether you are a defaulter or something like that. And nowadays, it is all online. Okay. Some common information all people should share with others.
Yeah,
Otherwise, if I don't reveal, others cannot reveal the same.
yeah.
That's why all these banks, what they do is they keep common information in a place so that all can access. So it can be an ODS kind of a solution for sharing purpose, common information to share. So from branch we keep, maybe it can be in between different branches or in between different banks itself, different different businesses also sometimes. They can share common information with ODS, or it can be simply for the purpose of integration. Okay. So these kind of terms we find different types of databases we come across. Okay, source like operational database or transactional database, like we come across data warehouses, data marts, or staging databases or ODS and all. Okay, different terminologies we can come across. Sometimes data might come from out of your organization. It can be an external database. So different terminologies. Okay. This is a scope of participating all this in an ETL. Okay. So from transactional database, data can come to staging, and then from there to mart, and from there to warehouse. It is a scenario. Or on my transactional databases, I have planned one integration, that is ODS. So ODS becomes my source for staging, and from staging mart and then warehouse. Or some information might come from external database.
Okay.
So this is all possible data flows.
Okay.
So
And also, Akul,
at any
in the middle, I have only small question. The transaction database to the ODS, what kind of process how there is no ETL level to bring the data here. What kind of process they do?
so actually here from ODS to transaction database, they don't actually extract, transform, and load the data here. Okay. In ODS, they can plan simply maybe some views, which will pull the data from actual tables. Like that, they can plan ODS. So I need not extract data from transaction till ODS. Okay.
Okay.
So through ODS, what I'm trying to do is I'm trying to reach to specific set of data, specific part of the database, not entire thing.
Okay.
That's why from ODS to database, it is OLTP there written.
Oh, the OLTP. Oh, okay, okay. Kind of just
transaction process.
they never use any
accessing.
Yeah, okay.
Like you don't extract and keep it here, but through ODS you'll be accessing both.
Oh, through okay. Yeah, we are accessing through the ODS.
Yeah. Like there it can be some views planned, okay.
Views.
Which can show specific data from both the sources.
Oh, okay.
Like that.
Right.
we don't move the data
Okay. Hmm.
because moving becomes duplication.
Yeah, I know. Yeah. So that means the staging level when we extract and loading for the staging level through from the ODS, then through the ODS this will access both transactional database through the ODS. That means staging level.
Yeah, yeah.
Okay.
So always there is no such rule that you have to do like this only. No?
Mm-hmm.
According to the requirement, according to the situation,
Mm-hmm.
according to the like scenario or maybe the experience,
Mm.
people can always play around with rules or they can change the rules. No?
Yeah.
Rules are always meant for breaking.
Exactly. Yeah. Yeah.
It's
Okay.
like in database it always
Yeah.
happens.
Yeah. Uh-huh.
In normalization it happens. No?
Mm-hmm. Okay. Now for the understanding purpose, I'm just asking.
Yeah, yeah, yeah.
Okay. No problem. Mm-hmm. Mm. So now it's clear this part.
So obviously, so conceptual knowledge definitely it will be helpful. So tomorrow what we'll do is we'll discuss few other concepts like mainly to understand the dimensional data model. Okay.
Or dimensional
So
data
to
model.
understand dimensional data model, we need to understand how the organization of data you find in targets, in data warehouses.
Mm-hmm.
So if we understand that part now, we can proceed with the actual stuff like informatic architecture components, and then the installation part configuration, and then beginning with tool and all that are possible.
Okay. Okay, not problem. And the
Okay then.
dimensional level, because I'm not so clear about it. So tomorrow we will talk in detail about dimensional level
Yeah, that's what. Tomorrow I'll make you understand
uh-huh.
what is that dimensional model. Okay,
model.
to understand.
Yeah. Okay.
So that discussions we do tomorrow. Okay.
Okay. Actually, if you please send me that PPT, whatever you are showing, that looks like very useful. So can you please send it to me across my email address through your organizer, whatever.
Or else you just type your email in the chat.
Uh-huh.
I will send it. Yeah.
Okay, okay. I will type it right now.
Yeah.
Okay. Actually, you got it.
Yeah, I got it.
Okay.
Okay.
So,
Okay then.
yeah,
So
okay,
we'll catch up tomorrow.
sure.
We'll continue our discussions. Okay.
It's the same time, right? Between 12:30 and 1:30.
Yes. Okay.
Okay, okay. Good. Thank you very much.
Yes. Yeah. I see.
The